Hello everyone. Today we shall be learning how to write the electronic configuration of elements starting from atomic number 1 to 30. So before writing electronic configuration, there is a few things we need to know, such as afbau principle. So what did afbau say? He says that, afbau principle says that electrons should field from lower energy to the higher energy subcells. So there are different subcells such as P, D, F. So electrons are supposed to be filled from the lower energy to the higher energy. So S is lower energy than P. Therefore, S orbitals will be filled first as compared to P. So that's what afbau said. So using afbau principle and also using this chart out here, I've drawn something out here. Using this one, we will try to write the electronic configuration. So first of all, let me explain you what actually is this one. So out here, this 1, 2, 3, 4, 5 are the number of cells, right? In class 8 we have studied, in class 9 also we have studied that there are different cells such as K cell, L cell, M cell, N cell, O cell. Then it keeps right from K to O. And these are the number of cells. So K cell, L cell, M, N and O cell. So there are number of cells 1, 2, 3, 4, 5, and these are the subcells S, SP, SPD, SPDF, SPDF, right? So using this one, we will try to understand how electrons are supposed to be filled and in which orbitals we are supposed to fill the electron first. So out here 1. So this line, whatever subcells will be in this line, these are 1, these are 2, this comes under 3, this comes under 4, and then this comes under 5. So if you're filling electrons in these s orbitals, you're supposed to write 5s. If you're filling electrons in these p orbitals, you're supposed to write 5p. If you're filling electrons in these d orbitals, since this is in 4, you're supposed to write 4f. If you're filling in these p orbitals, you're supposed to write 3p. Like, and similarly, and also out here. So if at first you're supposed to fill these s orbitals, second you're supposed to fill these s orbitals, third these p orbitals, again these s orbitals, this p, this s, d, p, s, d, p, f, d and f orbitals. So there I've drawn some lines out here. These parts are the starting part and these are the ending part. In simple way, if you are supposed to understand, just remember, look in this way. This is the starting point and this is the ending point. So start this way. First we'll fill this s orbitals, second this s, and then p, and then s, p, and then s, d, p, s, d, p, f, d, and then f orbitals. So this is how we are going to fill the electrons. And also you're supposed to know that in s orbitals we can accommodate 2 electrons, in p orbitals we can accommodate 6 electrons, in d we can accommodate 10 electrons, and in f we can accommodate 14 electrons. These are, so in orbitals, okay, there are different orbitals, s orbitals, p orbitals, d orbitals and f orbitals. So in s orbitals 2 electrons, in p 6, in d orbitals we can accommodate 10, and then in f 14. So starting from atomic number 1, we will start filling up the electrons. And also the number of atomic number are the number of electrons. So just understanding that way. If atomic number is 1, number of electrons is 1. If atomic number is 2, number of electrons is 2. Atomic number is 3, number of electrons is 3. So first of all, let's start from atomic number 1. So at first we have hydrogen. So hydrogen atomic number is 1. Atomic number is 1. So number of electrons is 1. So there are 1 electrons. So what did I say? Which is the first orbitals we are supposed to fill? We are supposed to fill the s orbital. This is the first s orbitals and this is 1. So I'll just draw the orbital 1s. 1s. So how many electrons we can accommodate in s? We can accommodate 2 electrons. So since there is 1 electrons, I will write 1. right? Since there is only one electrons, I'm supposed to fill only one electrons. So if now I'm supposed to write the electronic configuration, how will I write? Since this is 1s, I will write 1s. How many electrons are here? 1. So 1s, 1. So this is the electronic configuration of hydrogen. So now we'll go for atomic number 2. So in atomic number 2 we have helium. Number of electrons is 2. So again I'll just draw the s orbitals, 1s. Why am I not drawing 2s? Because 2 electrons, right? In 1s only we can fill 2 electrons. We don't need 2p now. So 2 electrons means 1, 2. There are 2 electrons. So electronic configuration will be 1s, 2. So this is the electronic configuration of helium. Let's go for lithium. Atomic number is 3, number of electrons is 3. So 1s. So there are 3 electrons. So if I just draw 1s, let's see whether it will be right or wrong. So I can fill here 2 electrons, right? 2 electrons. Lithium is having 3 electrons and we have filled only 2 electrons. So 1 more electrons is left. So what is the second one? If this is gone, the second one is this one. So I can write, and since this is 2, I will write 2s out here. So 1 more electron. 1, 2, 3. So the electronic configuration will be 1s2, 1s2, 2s, 1. So 2 plus 1 is 3. So their number of electrons is 3. So this will be the electronic configuration of lithium. Let's go for beryllium. Number of electrons will be 4. So now I'll draw this one again. 1s2, 1s, 2s. So there are 4 electrons. So 1, 2, 3, 4. So there are 4 electrons. What will be the electronic configuration? 1s2, 2s, 2. So let's see whether we are right or wrong. 2 plus 2. 2 plus 2 is 4. So number of electrons is 4. Always count the number of electrons after writing. It will give you a confirmation whether you have written correctly or not. Let's go for atomic number 5. We have boron, atomic number 5. So there are 5 electrons. 1s, 2s. So 1, 2, 3, 4. So I have filled 4 electrons. There are 5 electrons. So 1 more electrons is left. So let's see which orbitals is going to come now. So 1s is gone, 2s is gone. So the second one is 2p out here, right? So if this is gone, and then third one is 2p. Since it is in 2, so we'll write 2p out here. In 2p, we can fill, in p we can fill 6 electrons. And in p we have px. This will be your px, py, pz. So 1 more electrons will come here. So 5 electrons, right? So what will be the electronic configuration? 1s2, 2s2, 2p, 1. So this will be your electronic configuration. So 2 plus 2 is 4, 4 plus 1 is 5. So again, it is correct. There are 5 electrons. Let's go for atomic number 6. We have carbon. So number of electrons is 6. So I'll draw the orbitals again. 1s, 2s, 2p. So 1, 2, 3, 4, 5, 6. There are 6 electrons. Always remember in p orbitals, when we draw the p orbitals, so if I draw the p orbitals like this kind, I am not supposed to fill the electrons like in this manner. I am not supposed to pair them up. Okay, there are some rules. Some scientists have made some rules. So according to the rule, each electron should be filled first and then we can pair them up. Electrons will be filled in each subset, it's in orbitals, right? Px, Py and Pz. We will fill electrons in Px, Py, Pz and then we will start pairing them up. You cannot just pair them up at the first. So if I write the electronic configuration, I'll have 1s2, 2s2, 2p2. Since there are 2 electrons out here, 2p2. So this will be your electronic configuration of carbon. Let's try for nitrogen. Nitrogen, atomic number 7. The number of electrons is 7. So I'll not erase this one. So there are 7 electrons. So 1, 2, 3, 4, 5, 6 and then I'll put here one more. So this will be 7, right? 1, 2, 3, 4, 5, 6, 7. So if I write the electronic configuration, I'll have 1s2, 2s2, 2p3. So this will be the electronic configuration of nitrogen. Let's go for oxygen. Atomic number 8. Number of electrons is 8. So 1s, 2s, 2p. There are 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. So the electronic configuration will be 1s2, 2s2, 2p, 3 and then 4. 2p4. So this will be the electronic configuration of oxygen. 1s2, 2s2 and then 2p4. So again we have fluorine, atomic number 9. Number of electrons is 9. So 1s, 2s and then 2p. 1s, 2s, 2p. So there are 9 electrons in fluorine. So I'll fill them up. In 1s we can fill 2 electrons, in 2s 2 electrons, in p how many electrons are left? 5 electrons, right? 4, 5, 6, 7, 8, 9. So this will be this is how the electrons are going to fill in the orbitals. So if I write the electronic configuration, 1s2, 2s2, 2p5. So this will be the electronic configuration of fluorine. So now we'll go for neon. Atomic number 10. Number of electrons is 10. So I'll just draw here again. 1s, 2s and then we have 2p. So there are 10 electrons. In S we can fill 2 and then in P we can fill 6. So let's start again. 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons. So if I write the electronic configuration, I will have 1s2, 2s2, 2p, 6. So this will be the electronic configuration of neon. 1s2, 2s2, 2p6. So let's go for atomic number 11. So atomic number 11 we have sodium. So atomic number of sodium is 11 and there are 11 electrons. So let's draw the orbitals again. So 1s, 2s, 2p, sorry, I'll not draw now. So 1s, 2s and then 2p. There are 11 electrons. So let's start filling them up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me just write a little bit bigger this one. 1. So now if I feel like this kind, I have 10 electrons, but there are 11 electrons, so one more electrons is left. So now if I'm supposed to draw one more orbitals, but which orbitals am I supposed to draw? We'll check this one. So the 1s I've already drawn, 2s already drawn, 2p already drawn. So after p, what do we have? We have s, right? After p we have s, but which s we have? We have 3s. So out here one more s orbital, and this is your 3s. So now 10 electrons are already filled, one more electrons is left. That electrons will enter the 3s orbitals. So now we have 1s2, 2s2, 2p6, 3s1. So this will be your electronic configuration for sodium: 1s2, 2s2, 2p6, 3s1. So now we'll go for atomic number 12. We have magnesium. So this is here 1s, 1s, 2s, 2p, and then we have 3s, 1s, 2s, 2p, 3s. There are 12 electrons, so we'll start filling the 12 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons, 10, 11, 12. 12 electrons. So in magnesium have 12 electrons, we have filled the 12 electrons. So we'll write the electronic configuration. 1s, how many electrons? 2. In 2s, we have 2 electrons. In 2p, we have 6 electrons. In 3s, we have 2 electrons. So we have 1s2, 2s2, 2p6, 3s2. So this is the electronic configuration of magnesium. Aluminium. So atomic number 13. In atomic number 13, we have aluminium. One S, 2s, 2p, 3s. So aluminium atomic number is 13, and there are 13 electrons. So we'll start filling the 13 electrons again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 11, 12. So now we have filled 12 electrons. One more electrons is left. So now we'll see in which orbital that the last electrons will enter. So this is done, this is done, this is done, and this is done. So after this one, after P and S, we have again P and S, and this P is in 3. So out here we are supposed to draw 3P, 3P, right? 1S is done, 2S done, 2P done, 3S done. After 3S, it start from 3P. So this is here 3P, and the last electrons will enter out here. So how now we'll write the electronic configuration: 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 1. So this will be your electronic configuration of aluminium. Electronic configuration of aluminium: 1s2, 2s2, 2p6, 3s2, 3p1. So now we'll go for atomic number 14. Silicon. 14 electrons. So now I'll draw the orbitals again: 1s, 2s, 2p, 3s, 3p. 1s, 2s, 2p, 3s, 3p. So now these are the orbitals and there are 14 electrons. So we'll start filling the 14 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have filled the 14 electrons and now we will write the electronic configuration. So 1s, in 1s we have 2 electrons, in 2s we have 2 electrons, 2p, 6 electrons, 3s, 2 electrons, 3p, 2 electrons. So this is the electronic configuration of silicon. 1s2, 2s2, 2p6, 3s2, 3p2. Phosphorus atomic number 15, number of electrons is 15. So we have 1s, 2s, 2p, 3s, 3p. So now phosphorus we have 15 electrons. Atomic number is 15, number of electrons is 15. So we'll fill the electrons. In S we can fill 2 electrons. 2 electrons we can fill 6 electrons. Now it is 10, 11, 12, 13, 14, 15. There are 15 electrons and we have filled the 15 electrons. So now we will write the electronic configuration again. So 1s, 2, 2s2, 2p, 6, 3s2, 3p, 3. So this is the electronic configuration of phosphorus. 1s2, 2s2, 2p6, 3s2, 3p3. So now we'll go for atomic number 16. Sulfur, atomic number 16. So 1s, 2s, 2p, 3s, 3p. So atomic number is 16, number of electrons is 16. So now we'll fill the 16 electrons again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 electrons and I have filled the 16 electrons. So now I'll write the electronic configuration. So let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, right? So now we'll write the electronic configuration. 1s2, 2s2, 2p, 2p, 6, 3s2, 3p4. So this is the electronic configuration. The p orbitals is increasing, right? Previously we have 3p1, 3p2, 3p3, 3p4, 3p5, and then till 3p6. So we have 1s2, 2s2, 2p6, 3s2, 3p4. Let's count, okay? Let's see whether we are right or wrong. So 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 4, 16, right? So number of electrons is 16. So we are right. Let's go for atomic number 17. Chlorine. Atomic number 17. Number of electrons is 17. For chlorine, atomic number is 17. Number of electrons is 17. So let's fill the electrons again. 1s, 2s, 2p, 3s, 3p. 1s, 2s, 2p, 3s, 3p. So how many electrons? 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15, 16, and then 17. There are 17 electrons. So if I write the electronic configuration, I can write 1s, 2, 2s, 2, 2p, 6, right? Why 6? 1, 2, 3, 4, 5, 6. 6 electrons. 6, 3s2, 3p, 5. So we have 1s2, 2s2, 2p6, 3s2, 3p5. So this is the electronic configuration of chlorine. Let's go for atomic number 18. Argon. We have atomic number 18. So let's fill the L. So 1s, 2s, 2p, 3s, 3p. So atomic number argon is 18, number of electrons is 18, so we'll fill the 18 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I have filled the 18 electrons. So now I'll write the electronic configuration. So 1s2, 2s2, 2p, 6, 3s2, 3p, 6 electrons, right? So 3p6. So this will be the electronic configuration of argon. 1s2, 2s2, 2p6, 3s2, 3p6. So now atomic number 19, number of electrons is 19. So we have potassium. So there are 19 electrons. So let me draw again. 1s, 2s, 2p, 3s, sorry, 3s, 3p. 1s, 2s, 2p, 3s, 3p. Yeah. Potassium atomic number is 19 and the number of electrons is also 19. So we'll try to fill the 19 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have filled the 18 electrons. So one more electrons is left. So after 3p, which orbitals we are supposed to draw? We'll check this out. So after 3p, I'm supposed to draw 4s, right? So after p, we have s. So 4s. So out here, I'm supposed to draw 4s. So the last electrons will enter in 4s. So now if I write the electronic configuration, I can write 1s, 2 electrons, 1s2, 2s2, 2p, 6, 3s2, 3p, 6, 4s, 1. Since there is 1 electrons, I can write this kind. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. So this is the electronic configuration of potassium whose atomic number is 19. So now we'll go for atomic number 20, calcium. Atomic number 20. So we have calcium, which is 20. Number of electrons will be 20. So now how the electrons are filled? 1s, 2s, 2p, 3s, sorry, So 1s, 2s, 2p, 3s, 3p, 4s. So 1s, 2s, 2p, 3s, 3p, 4s. So there are 20 electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there are 20 electrons. So now if I am supposed to write the electronic configuration, this is how I'm going to write again. So 1s, there are 2 electrons, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So this will be your electronic configuration for calcium: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So let's try for atomic number from atomic number 21 to 30. So atomic number 21, scandium, we have 21, number of electrons is 21. So I'll draw the orbital: 1s, 2s, 2p, 3s, 3p, 4s, 4s, and then we have 3d: 1s, 2s, 2p, 3s, 3p, 4s. So let me not draw this one first. So now there are 21 scandium atomic number is 21, and there are 21 electrons. So this is how I'm supposed to fill. 21 electrons means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have filled 20 electrons. One more electron is left. So now we are supposed to see after 4s, which orbitals are we supposed to draw. So 1s, so this is 1, 2, 3, 4, 5. So 1s is done, 2s, 3s, 4s, right? This is your 4s. So after 4s, we have 3d, 3p, 3d, 4p, and then 5s. So after 4s, we have 3d. I'm supposed to draw the 3d orbitals. And in 3d orbitals, we can accommodate 10 electrons. So 1 electron is supposed to enter the d orbitals. So this is how we are supposed to put the electrons. So if I write the electronic configuration, I will have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So this is the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. So now if I go from atomic number 21 to 30, it keeps on increasing. The d orbitals will keep on increasing. So we'll have 3d. Now we have 3d1. So second we'll have 3d2, 3d3, 3d4, 3d5. Keep on going. So now let's try for atomic number 22. Ti, we have 22. Number of electrons is 22. So I'll not fill here. So titanium is 22 and number of electrons is 22. So out here I've already filled 18 electrons, right? 18 and this 22, 18, 19, 20, 21, 22. So I have filled 22 electrons. So if I write the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. So this is the electronic configuration of titanium: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d2. Let's go. I'll just erase this one now. So now we'll try for atomic number 23, which is vanadium. So we have 23 out here. Number of electrons will be 23. So out here I have already filled 18 electrons. So I am supposed to fill some more electrons. So 18, 19, 20, 21, 22, 23. So I have filled 23 electrons. So now if I write the electronic configuration, I will have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. So this will be the electronic configuration of vanadium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d3. So now we will try for atomic number 24, which is chromium. So out here we have chromium 24, number of electrons 24. So I'll just remove this one. So now I've already filled 18 electrons, so some more electrons is needed. 18, 19, 20, 21, 22, 23, 24. So I have filled 24 electrons, but this is wrong. I cannot fill electrons in this way for chromium. Why? Because chromium is exceptional. It means that in chromium, what happens is out here. So if I fill the electrons like this kind, there are 4 electrons. So if I put one more electrons out here, it will be half filled. And one thing we should know is that half filled and fully filled are highly stable, and we should always try to keep them in stable state if possible, right? So now if I put 1 electrons out here, this will be half filled, right? All of them will have one electron each, so it will be half filled, so it will be highly stable. And also that this is going to have, it means that this is going to have lower energy as compared to 4s. So therefore in chromium, instead of putting 2 electrons in 4s, 1 electrons will enter out here in 3d. So out here in 3d we will have 5 electrons, and in 4s we will have 1 electrons. Why? Because in 3d, if you give 1 more electrons, it will be half filled, it will be highly stable. And then why it's being filled? Because this is having lower energy as compared to 4s. So this is how the electrons will be filled in chromium, and it is exceptional. Okay, so now if I write the electronic configuration, I will have 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. So this will be the electronic configuration of chromium. So now we will try for atomic number 25. Manganese, right? So now atomic number 25, number of electrons is 25. So out here I have already filled 18 electrons. So now 18, 19, 20, 21, 22, 23, 24, 25. Only chromium is exceptional. There may be some more exceptional elements, but now we have come across only chromium. Manganese is not exceptional anymore. So out here 18, 19, 20, 21, 22, 23, 24, 25. So this is how the electrons will be filled for manganese. So this will be the electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Now if I go for 26, I will have iron, right? Iron is 26, atomic number 26. Number of electrons will be 26. 18, 19, 20, 21, 22, 23, 24, 25. If I put here one more, I will have 26. This is how the electrons will be filled for iron, right? I've just put here one more electrons. So if I put here one more electrons, how many we have? 1, 2, 3, 4, 5, 6. We have 6 electrons. So now I will put here 6. So this will be the electronic configuration of iron: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now we will go for atomic number 27, cobalt. So now again 18 electrons, right? 18, 19, 20, 21, 22, 23, 24, 25, 26. If I put here one more, I will have 27. So now out here, how many electrons I have? I have 7 electrons. So I'll just increase out here by 7. So this will be the electronic configuration of cobalt. So now similarly we'll go for nickel, which is 28. Out here I have 28. Number of electrons will be 20. This is the atomic number. So now 28, 18 electrons, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, right? So now how many electrons are out here? There are 8 electrons. So now I will just increase by 1. I will write 8. So now this will be the electronic configuration of nickel. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d8. So now we have atomic number 29, which is copper. So number of electrons is 29. So we'll start filling 29 electrons. So out here I have already filled 18 electrons. So 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So this is how we are supposed to fill. But this is again wrong, just like chromium. So what happens is, in chromium it is trying to be half filled, whereas out here it will try to be fully filled. So if I put one more electrons out here, it is going to be fully filled. So just like chromium, from here 1 electrons will jump to 3d orbitals and making it fully filled. Now all of them are pair up and then they are fully filled. So as I've told you earlier, just like chromium, copper is also having some exceptional cases. So therefore now the electronic configuration. So this is how you're supposed to fill copper, and then the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So the electronic configuration of copper will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. As I've told you earlier, 1 electrons from 4s will jump to 3d orbitals, making it fully filled. Why is it making fully filled? Because it is highly stable and also it is having lower energy as compared to 4s. So electrons will fill the d orbital first as compared to the s orbitals. So now for the last we have atomic number 30, which is zinc. So zinc atomic number is 30 and number of electrons is 30. So now I have already filled 18 electrons here. Now again 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So I have filled 30 electrons. So the electronic configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So this will be the electronic configuration of zinc: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. So by this we finish writing all the electronic configuration